Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video, we are going to solve question 56 of the JAM 2024 chemistry paper from the NAT section on numerical answer type, that is based on Raoult's law. Okay, Raoult's law is part of relative lowering of vapor pressure, and this is the formula that we are going to use. Okay, so first let us write down the given data. The total vapor pressure, P total vapor pressure of binary liquid mixture of benzene and toluene is 0.3 bar. Okay, total vapor pressure is given to us. Then the vapor pressure of the pure benzene is 0.5 bar, that is pure means you add 0. Okay, of benzene I will write B, that is 0.5 bar. Then pure vapor pressure of toluene is given, that I will write it as P0T, that is 0.2 bar. What we have to calculate is the mole fraction of benzene, that is unknown. Okay, so now let us understand what are the formulas that we have to use. First, the total vapor pressure is given. Okay, total pressure is given, that is, what is the formula for that? Partial pressure of benzene plus partial pressure of toluene. Okay, P stands for what? P stands for partial pressure of any component. Okay, partial pressure is P. Okay, so first what we have to calculate? We have to calculate both this. Now, according to the Raoult's law, what is the formula? Partial pressure is equal to the vapor pressure of the pure component multiplied by the mole fraction. Okay, P is the partial pressure of any component. Okay, in a gas mixture, P0 is the vapor pressure of the pure component of the gas, and X is what? X is the mole fraction. Okay, so what is PB? PB will be pure pressure, vapor pressure of benzene, that is 0.5 bar. Okay, multiply by mole fraction of benzene. Now what we have to find out? We have to find out the mole fraction of benzene. Right, so we'll leave this equation as it is. Next, partial pressure of toluene will be pure vapor pressure of toluene, that is how much? 0.2 bar. Okay, multiply by mole fraction of toluene. Okay, now we don't have the value of mole fraction of toluene. So what we will do, we'll substitute. We know the sum of the mole fraction, that is of benzene plus toluene. Okay, sum of the mole fraction of all the component is equal to 1. So what will be mole fraction of toluene? 1 minus mole fraction of benzene. Okay, so this will substitute 0.2 into mole fraction of toluene is 1 minus mole fraction of benzene. Okay, this is equation 2. This is partial pressure of toluene. Now both these 1 and 2 we will substitute in the total pressure equation. Okay, so let me erase this first. Okay, we have to just substitute and then calculate the value for the mole fraction of benzene. Okay, so the total pressure, okay, total pressure is how much? That is given 0.3 bar. 0.3 is equal to partial pressure of benzene, that is from equation 1, it is 0.5 into XB, that is mole fraction of benzene, plus partial pressure of toluene from equation 2, it is 0.2 into 1 minus mole fraction of benzene. Okay, open the brackets, this will be 0.5 XB plus 0.2 into 1 is 0.2 minus 0.2 into mole fraction of benzene. Okay, so 0.3. So this 0.2 plus 0.2 will go on the left hand side. It will become 0.3 minus, plus will become minus, and 0.5 xb minus 0.2 xb, that will be 0.3 into mole fraction of benzene. Okay, so this 0.3 minus 2 is 0.1, that will be 0.3 into mole fraction of benzene. Okay, so what will be mole fraction of benzene? XB, mole fraction of benzene, will be 0.1 divided by 0.3, that will be 1 by 3, that is up to how many decimal places? 2, 0.33. Okay, so the answer is how much? 0.33. And the range, if you see what is given, okay, the range that is given for this is 0.32 to 0.34. 0.32 to 0.34. What is the meaning of this? If you write 0.32, your answer is correct. 0.33, that is what we have got, that is also correct. If you have got 0.34, that is also correct. Okay, only these three answers are acceptable. Okay, I hope you have understood the solution. Thank you.